Hello, good afternoon everyone and welcome back to SISYA CLASS YouTube channel. Today we'll be continuing our JEE Maths Foundation series with the chapter Time, Speed and Distance. We have learned in the smaller classes. Now we'll look at the basics and we'll also learn the concept of relative time, relative speed and different concepts. So let me introduce myself. I am Pawan Yashwant. I have a graduation in Bachelor's in Technology from Gandhi Institute of Technology and Management, Visakhapatnam. I have an experience of 5+ years in which I have taught over 20,000 plus students. Let us see what speed is first. So speed is the distance covered per unit time. Let me give you an example for that. You have a person, right? You have person. He is walking a certain distance. Let me say this as 150 centimeters. Now the time he takes to cover this 150 centimeters, I have this in front of me 150 centimeters, right? If I'm covering this in assuming 3 seconds, let me take 3 seconds. I have this distance covering in 3 seconds. So my speed would be the distance I covered and divided upon the time I have taken. So that is what speed is. Speed is nothing but distance upon time. And you can interchange this. You can get time by dividing distance by speed, and you can find the distance I walked by multiplying with the speed and the time I have taken, right? So let us continue. So two bodies travel with same speed, then the distance covered varies directly as time. It is shown as distance is proportional to time. It's nothing, it's a simple concept, Nana. If two bodies travel with same speed, let me tell you, I have myself, right? I am walking a certain distance with a constant speed. Now, what is it saying? Then the distance covered varies directly with that time. The time I have taken to cover this distance, it increases proportionally as I increase my time. If I cover 2 seconds, 2 meters in 2 seconds, it will be increasing proportionally on covering up more distance. If I take it 4, it will be increased by twice. Now second, two bodies travel the same distance, then the time varies inversely as speed. So basically time is inversely proportional to speed. You have many examples, right? If time is increasing, speed is decreasing, right? Time is inversely proportional to speed. Let us assume you are walking, right? You are walking 0 to 3 meters in 5 seconds. Now 0 to 5 meters, you are walking in 5 seconds. Now if I'm increasing my speed, right? If I cover this, so basically if I increase my speed, let me take this as 5 meters per second, 1 meter per second, 1 meter per second, right? If I'm walking faster, if I'm covering this in less time, 3 seconds. So you can say that when time is getting increased, the speed is getting reduced. That's the concept here. So come on, how do you convert kilometer to meter per second? So in your questions, you will be given one part of the question in kilometers. Let's just say two people are covering 6 kilometers, or they have a relative distance or the difference between 6 kilometers, 8 kilometers. Now, and the time will be given in seconds. Okay, they are 2 seconds apart, they are 10 seconds apart. So we have to convert either of these entities into meter per second or kilometers per hour. How can we do that? If you have 1 kilometer per hour, how can you convert it into meter per second? 1 kilometer, it would be 1000 meters, right? Upon 1 hour. 1 hour has 60 minutes. 1 minute has 60 seconds, so it will be 3600 seconds. Right? It will be 3600 seconds. If I cancel them out, this should be 5 upon 18 meter per second. So if you have any quantity that is given in kilometer per hour, you can directly use this relation and multiply that amount with 5 by 18 to get it meter per second. So let us check this. So to convert speed kmph to meter per second, we have to multiply it with 5 by 18. And if we have to convert meter per second to kilometer per hour, we have to multiply it with the reciprocal of this, which is 18 upon 5. If you understood here, let's go. So average speed, the average speed of a body traveling at different speed for different time periods. Average speed, Nana. See, you are traveling from one point to another point, right? You're walking or running from point A to point B. Now it is highly unlikely that you will be covering the distance in the same speed. You won't be taking 40 kilometers per hour or 60 kilometers per hour, right? Your speed will be varied, right? You would be coming up with 40, you would be coming up, then you might increase your speed, then you might get a halt, the speed might become 0. So average speed is nothing but the average of the total speed you have taken. It is simply given by distance upon time, right? So average speed is given by total distance traveled upon total time taken. So if you know the total distance you have covered and the total time you have taken, you would get the average time. Average speed, distance upon time. So next we have this important thing. When the distance traveled is constant and two speed is given, two speeds are given and the distance traveled is constant, the average speed is given by 2xy by x plus y, where x and y are two speeds at which the corresponding distance has been reached. So in this, distance is constant, Nana. Let me take two speeds. If I am covering this point to this point, which has a distance of some x in y kmph, and I am traveling it back to the starting point. For this, I will be covering it in some z kmph, right? So my average speed would be 2xy upon x plus y. And second case, now when the time taken is constant, average speed is calculated by the formula. If you have a constant time taken is constant, then your average speed is nothing but sum of speed, that number of speeds you are taking depending upon the and dividing upon by the total number of those number of speeds. Right, x plus y are two different speeds in this case. X and y are two speeds at which we cover the distance for a identical time. So time is identical in this case, right? Let's continue. Now relative speed, the concept of relativity, we'll see what relative is. So it is a extremely regular or generalized concept. You see it in every day. Let us assume you are in a railway station, right? You're standing on some platform. You have a train in front of you. Now there will be trains moving, right? There will be train moving ahead or backwards, any direction. So standing on the platform, you can see that the train is moving. Now let us assume there is a person sitting inside the train. Who is seeing you, right? Now for that person, he is constant, but the things around him are moving. That is what relativity is. It changes from perspective to perspective, right? That is the concept of relative speed. The speed of one moving body in relationship to another moving body is called relative speed. Now I am moving, you are constant. Suppose if you are moving and I am constant, you just feel it like that. So that is what relative speed is. It changes from body to body, right? Now if two bodies are moving in opposite direction, then the relative speed is equal to sum of the speeds of their bodies. Let me tell you. You are moving in this direction, right? And there is one more person who is moving in this direction. Now, for this case where your directions are opposite, one is moving this side and one is moving this side. So, in this case, opposite direction, the relative speed is equal to the sum of the speeds of the two bodies. So, the speed of this and the speed of this is the sum of these two speeds and they are in opposite direction. Okay, let us see trains. It's an important concept. Trains is a very important concept that you need to learn. You will be getting different types of sums on it. So let us see what is written. When a train passes a stationary object like platform, bridge or another train, the total distance it travels is the sum of its own length and the length of the object that it's passing. This is because the train must cover its entire length in addition to the entire length of the stationary object to completely clear it. So let me take an example. So this is the train, right? So this is the train. So this is moving in, let us say, this direction, right? This has some length, right? A train definitely has some length of x meters. Now, it is going under a tunnel right now. Assume this is a tunnel. This is a tunnel of some kind. Now, what is saying, if it has to cross this part, you have to both consider this length. The tunnel will be of some distance. It will be 1 kilometer, half kilometer, 2 kilometer. You should consider the length of both the train and the object, or in this case we are using a bridge. This could be a platform, this could be a bridge, or this could also be another train. If you have one train moving like this or any direction, you can consider that time. So in this case you have to add both the distances, since it has to cover the distance of its own and the train, right? This is the first part. Now coming to second, when a train is dealing with another moving object, moving train, whether it's overtaking in same direction or crossing same or opposite direction, the total distance it need to cover is combined length of both the trains. However, the speed at which the distance is covered isn't the train's individual speed, it's their relative speed to each other. Let us check. When a train is using, so there is one more train involved, right? There is one more train. Now, so it's overtaking this. So it can overtake in two ways, right? If both are moving in the same direction, this will go faster than this train in order to overtake it. That's the one thing it can do. And opposite direction, this can be any case. Either this can be fast, or this can be fast, or both can be of equal speed. In this case, they have to cross each other, right? Same or opposite direction. The total distance it need to cover, the total distance this thing needs to cover would be the combined length of both the trains. So it need to cover the length of both the first train and second train. However, the speed at which this distance is covered, so the speed here is not the individual speeds of the train 1 and train 2. If this is x kilometer per second or this is y meter per second, this is not directly the speed at which this train is covered. It's the relative speed. It's their relative speed to each other, right? Okay. Now, coming to this, the important thing, let us assume there are train and some item. Let me take a train. So this is a train, right? Let me assume this is a train and this is a object. So let st be the speed of the train. This is moving, let me say, at st. This is moving at st. Lt be the length of the train. So this is the length, right? This should be Lt. Now, Si be the speed of the item if this item is moving, right? If this item is moving, this will be Si. And the length of this item be Li. This is the length of the train, this is the speed of the train, and this is the length of the item, this is the speed of the item. Both are in motion or of that sort. And T is the time taken to cover, right? Now, train crossing a stationary item, okay. Stationary means this is not moving, this is constant, this is constant, this is stationary. Now, train crossing a stationary item without length. So, if this does not have length, the equation would be speed of train into length is equals to, speed of length into train is equals to length of train, right? If this object is completely covering this stationary item, the length of the train is given by st into t, the time taken for it to cover that part. Now train crossing a stationary item with length. Now this thing has some length, okay, this thing has some length. So basically length, or it does not have length, you can assume a pole, right? A pole's length is negligible. So you could use a pole, it's negligible. This is an example of that case. So train crossing a stationary item with length. If this thing has length, the formula would be st into t is equals to lt plus li. Okay, just a second, lt plus li, yes. So speed of train into time taken to cover is equals to length of train plus length of the object. Got it. Chalo. Now let's see what acceleration is. Acceleration is nothing but the rate of change of velocity. If your speed is changing, you are going at some 20 kilometers per hour. Now you are trying to increase the speed. That increase in speed is called acceleration. So it's represented by A. Let's say it. So if you want to know the final speed, you can use acceleration to find the final speed. How? Initial speed, the speed at which you start. If you're starting from rest, initial speed would be 0, plus acceleration. If you are accelerating the vehicle by 2 meter per second square, acceleration would be meter per second square, and the time taken for you to accelerate, the time you're taking to accelerating the vehicle, right? The time you're taking to reach 20 to 30, right? This time and this acceleration. Okay, if you're moving from 20 kmph to 30 kmph, let me assume you're on 2 meter per second, and the time taken for that to reach this speed. Okay, let us continue. So this is a simple question we have right now, right? Just a second. What is the time taken by a 180 meter train running at 54 kmph to cross a man standing on a platform? See, man is of negligible length. He's a stationary item without any length. So let me draw. This is a train. The length is 180 meter. The speed is 54 kmph. Now let us see, this is moving like this. Here there is a man, right? How can you do this basically? So time is equals to distance upon time, speed. So what is the distance in this case? 180 upon speed is 54. Can you write 54? Obviously you cannot, because this is in meters and this is in kilometers per hour. You can convert this. 54 into 5 by 18. Okay, 9, 27. This should be 15. So this would be, time taken would be 180 upon 15, which is speed, distance, meter per second. So this would be 12 seconds. So this is the time taken for this train to cross this man, right? This is basically the length of the train we are considering this in this case. Chalo. Now, how long will a train 100 meter long traveling at a speed of 45 kmph take to cover a platform of length 150 meters? In this case, we are using a stationary object with length, right? So this is the train. Okay. The speed is 45 kmph. Okay. The length would be 100 meters. So if you see in this case also, you have kmph and you have meters. So this is moving like this with 45 kmph. Now you have a platform. You don't know the distance, so you can take anything. You can just consider it platform. The platform length would be 150 meters. Let me just check. Okay. Platform length is 150 meters. So what we have studied, if it's crossing a platform of length, so it needs to cover both the train length and both the length of the platform, right? So total length would be 100 plus 100, yes, 100 plus 150, that should be 250. Now speed, right? We know speed is given in kmph. Let us convert this. 45 into 5 upon 18. This should be 12.5. Okay, you know the length, you know the speed, you can find the distance, right? Sorry, you can find the time. You have asked what is the, how long means it's asking about time. So time would be distance upon speed, that is 250 upon, right, 12 point, just a second. This should be 20 seconds. Okay, in this case, the train has to cover both 100 meters and 150 meters. Chalo. Now, a train crosses two persons who are cycling in the same direction as the train in 12 seconds and 18 seconds respectively. If the speeds of the two cyclists are 9 and 18 kmph respectively, then find the length and speed of the train. Okay, let me tell you this. Okay, you have a train. You have a train, right? Now let us assume this is moving. Now we have two persons who are cycling in the same direction. So this is a cycle. Let me draw something of this sort. Now, what is he given in the question? This is a train. Now, this train is crossing these bicycles or cycles in 12 seconds. To cover this bicycle, it is taking 12 seconds. Now, to cover this or to cover this second bicycle, it is taking 18 seconds. It is taking 18 seconds. Okay, this is the question. Now, if the speeds of these cyclists are 9 and 18, okay, the speed would be 9 kmph and 18 kmph. Okay, these are the two speeds of the two bicycles. Now, then find the length and speed of the train. Let us assume the speed of the train be s. Now, we have the speed of the train as s. So, the first cyclist would be covering this as the relative speed, you could say, in cyclist 1 speed, something of that sort would be s minus 9, right? S minus 9 kmph. Okay, now if we do it in the second case, or let me tell you, now the time taken to cross this time would be 12 seconds. Now guys, this is basically his moving after a cyclist. The length is negligible because he has not mentioned any length. So how can I do this? I can find the length of the train using this, right? Length of the train would be, let me take length of the train would be distance into speed, right? Distance into speed, which is s minus 9. Sorry, distance into time. Sorry, speed into time. This is speed into time, 12. Right? We have this into 5 upon 18. Got it? We are converting this into meter per second. Okay, because we have time in seconds. Now similarly, distance is equals to speed into time. We are converting this into meter per second or meters in this case. So first case we have this condition. If you closely look at the second condition, this is moving at a speed of 18 kmph, right? And 18 seconds. The train is covering this cyclist in 18 seconds. So this equation would be same, right? Just the numbers would be changing. S minus 18 into how many seconds? 18 seconds into 5 upon 18. Basically length of the train. This is also the length of the train. If you see, in both the cases the length of the train would be equal. In both the cases the length of the train would be equal. I can equate both of this. So s minus 9 into 12 into 5 upon 18 is equals to s minus 18 into 18 into 5 upon 18. Right? Understood this? I hope you all understood this. So this would be 2s minus 18 is equals to 3s minus 54. This should be, s should be 36. So this is 36. Now we have s. Let us find, we have speed as s. We can find the length of the train by putting this equation, this number in this, again the above equation. We can directly put in this, which should be 3 9s 6 2s 18 5s 90 meters. So this is how we have solved this. We first took this diagram where the train is crossing this first cyclist in 12 seconds. This cyclist is moving in 9 km per hour, and the second cyclist who is moving in 18 km per hour, the train is covering him in 80 seconds. So we have constructed the first equation using the first train. Then the speed of the train, we consider it as s. Then we have first cyclist, the speed would be s minus 9, right? Friend is moving s minus 9. Now the time taken is 12, so we construct that the length of the train. The train needs to cover the cyclist. The cyclist has no length of his own. So this is the equation, s minus 9 into 12 into 5 by 18. The second equation at which is 18 kilometers per hour. He is moving at 18 kilometers per hour into 18 seconds. The train is covering him in 18 seconds, and the conversion factor, which is 5 upon 18, is the length of the train. Since both the values are equal, we are finding speed as 36 meter per second. Now we have put this length in directly any of this equation. We have used the first equation, right? So the length of the train would be 90 meters. Okay. Next we have, in a 100-meter race, Tina beats Meena by 20 meters. Okay, if Tina beats Meena by 20 meters means if Tina is covered, okay, the distance is given 100 meters. Let me write. Tina beats Meena, that should be 100 by 80, because when she is at 8, Meena is at 80, Tina has completed her 100-meter race. Got it? Okay. And in the same race, Meena beats Rita by 10 meters. Meena by Rita by 10 meters. Now she is 90, you 80, so you can put 80. No, let us not do that way. This means if Meena is completing the race after completing 100 meters, Rita is completing 90 meters. Now they have asked us to find the relationship between Tina and Rita. Tina and Rita. Got it? If you multiply both of them, the Meena won't be there. You will be getting the relationship that exists between Tina and Rita. So Tina is to Rita. Is given by 100 upon 80 into 100 upon 90. So 0, 0, 0, 0. This should be 100 upon 72. Okay guys, hope you understood this, right? If you want to directly put 80 here, you can also do this. If you are putting 80, it should be 10 meters, right? So you have to compare it with 100%, remove the 8, you will be getting 72. Got it? 80 minus 8, 80 minus 8 would be, 72. So 100 upon 72, that's what you have got in this case. So if Tina is completing 100 meters, Rita is completing 72 meters. So Tina is beating Rita by how much? 28 meters. Hope you understood this sum. Chalo, let's continue. Okay. Now, two trains start at the same time from Pune and Delhi and proceed towards each other at 80 kmph and 95 kmph respectively. When they meet, it is found that one train has travelled 120 km more than the other. Find the distance between Delhi and Pune. Let us take 2 points. Okay, let me do this. Let me write this as Delhi. Okay, wait. First we have Pune, right? Let's write Pune in this case. Okay, we have Pune. And we have Delhi. Now, this is the two parts. Now, one train is moving like this and one train is moving from Delhi towards Pune. See, they're starting at the same time from Pune and Delhi and proceed towards each other at 80 kmph. So Pune, this train is moving in 80 kmph. Let me write this 80. Okay, this is moving at 80 kmph. Now Delhi, the train from Delhi is moving at 95 kmph. Okay, you understood till here, right? Now when they meet, it is found that one train has traveled 180 km more than other. Obviously, if you can see in this case, no other condition you are considering, and you can see that the speed is more of this Delhi train, so it will cover more distance than what Pune train would be covering. Let us assume this is the point. This is like middle, right? Let me write it. Now let me consider this is the meeting point, right? This is the meeting point. This point, both the trains would be meeting. Now if you take this distance as x, right? If you take this distance as x, this train has covered 180 km more than the other, so this should be 180 plus x. Okay, it has covered 180 plus x to reach the same point. Okay, if you see, this is the question now. Now second most important thing to remember here is that time at which they are meeting is same, right? If even the Delhi guy is meeting this Pune guy after some 5 hours, 4 hours, but the time is same. Both are starting at the same time and they're meeting obviously at the same time. So the time would be equal. So if we use for 1, let me take the Pune case. So this should be speed into time. Time is constant. Let me keep it like this. Now second case. This Delhi train is moving at 95, right? This should be 95 t. Now if you see, let me tell you just a second. If the combined, they are moving 2x plus 180, got it, 2x plus 180. If I subtract both these equations, or the difference of the distance that exists between these two is 180 kilometers. Since this train is covering more distance, the difference between of distance covered by this train, distance covered by this train would be 180 kilometers. That's the question, we are just representing it. So I can write that 95 t minus 80t is equals to 180. Okay, so this would be 15t is equals to 180. T would be 180 upon 15, which is 12. Units, all are in kilometers per hour, and yeah, everything is kilometer per hour. Distance is also kilometer, so it will be hours, 12 hours. So after 12 hours, the train from Pune and the train from Delhi would be catching each other. That's the question. So now we have to find the distance. You can easily find it because you know the time. You can directly put in any of this equation, right? We have total distance would be 95t plus 80t. So this should be 175 into t. That is what we have gotten, right? This distance from here to here is 80 into t, 80 kilometers per hour into 12 hours, and this should be 95 kmph into the time taken. So this should be, we have 12, right? 175 into 12, which is 21, right? Yep, 2100. So this is how we have solved it. We first considered that they are meeting at this point, and the time taken to reach this point will be same for both the trains. So this covers an additional of 180 kilometers since it is moving more speed, moving with more speed. So we found out the distances using the time, which is constant in both the cases. So in this it is 80t, we have 95t, and the distance between both the trains, or the train Delhi train has covered more distance, we have subtracted the distance to find out the time taken. They'd be meeting after 12 hours. So the total distance would be the distance covered by train 1 and train 2, which is 2100 km. Chalo. Now, this is an easy question. It is an asked in Ames 1995. A boy walks to his school at a distance of 6 kilometers with a constant speed of 2.5 kmph and walks back with constant speed of 4 km per hour. His average speed is expressed. See, this is the first case we have studied, right? Let me just take you. Yep, relative speed. So see, in this the distance is constant. In this case, the distance is constant. He is moving to his somewhere and is again coming back to his home, right? So we can do this by this formula. So he is moving home to, okay, he's starting at, okay, let me take his home and his school. He is moving, this distance would be 6 kilometer with a constant speed of 2.5 kilometer. So he is moving this at 2.5 kilometer per hour. Now, he is coming back, he walks back at a constant speed of 4 kilometer. He is coming back faster. He wants to come home faster. So he is walking faster. And that you can find that average speed, which would be 2 into 2.5 into 4 upon 4 plus 2.5. which should be 5 into 4 is 20, 20 upon 6.5, which would be 200 by 65, 5 40s and 5 13s. This is extremely formula related question you have. That's it, right? Now coming to the next question. Now, a passenger is sitting in train A moving at 90 km per hour. Observes another train B moving in the opposite direction for 8 seconds. If the velocity of the train B is 54 kmph, then the length of the train B is, okay. You have a passenger, right? He's sitting here. Now, he's seeing another train. He's moving in this direction. He's moving in this direction, opposite direction, right? It's moving in the opposite direction for 8 seconds. So guys, here the important thing to remember is he is not looking at the train after it has covered a certain distance. You know, the train passed by, then he saw the compartment that is, and it took 8 seconds from then till covering the train. It's not of that question. It's this type of question where the starting, he's saying the opposite train from starting. You have to consider it like that. From starting, he just saw the starting point of the train which was moving in the opposite direction, and it took 8 seconds. Where is it? 8? Okay, yeah, it took 8 seconds for the train to completely pass after him. So when the train is in this position, it took him 8 seconds. Okay, this is the question, right? If the velocity of train A, so this train, the first observer is moving in 90 kmph. Now, the velocity of train B is 54. So this train would be 54 kmph. Right? Now, what is he asking? Length of train B. So he wants to find the length of this train. Got it? So we'll apply the concept of relative velocity, relative speed, you could say. Now we have studied earlier that if the trains are moving in opposite direction, the relative speed is nothing but the sum of the speeds. So velocity of A, B would be velocity of A plus B, which is 90 plus 54, which is 144. So now you found out the relative speed. Now let me, here it's 8 seconds, right? I can easily convert this into meter per second. 144 into 5 upon 18, which would be 5 cancel, 40 meter per second. This is 40 meter per second. So now we have got this as 40 meter. Relative speed would be 40 meter per second. Now he is watching the train for 8 seconds. Let me draw it again. Now we have the relative speed. He is watching this for 8 seconds. So basically he is watching the distance in 8 seconds with a speed of 40 meter per second. So you can easily write that distance, or thus distance, which is the length of the second train, is nothing but relative speed, which is 40 meter per second into the time taken. Got it? Meter per second into this time, which is second. So here L2 would be 0032 meters. Understood? He saw this train, and the relative speed of that train would be, relative speed of this thing would be how much? 40 meter per second, and it is moving for 8 seconds. So it's basically the product of this 2, 40 and 8, which is speed and time, right? Hope everyone understood this class, right? And if you want to learn more topics like this and have a better foundation, want to crack the IIT JEE examination, we at SISYA class are coming up with a SISYA elite batch. This is for grades 8, 9, 10th, 11th and 12th, guys. A course completely crafted by the IITians themselves. Now you'd be asking me, sir, I'm in 8th class, I'm in 9th class, I'm in 10th class. Why should I start so early? Why should I, study so early in this age? Let me tell you, the first reason I would say is competition. This exam, more than 13 lakh aspirants appear on a regular every year. This year we have seen around 13.5 lakh people appear in this. And out of the 13.5 lakh people, around 2.5 lakh people have gone to the advanced level. And merely thousands of them cracked the final IITs. Right? So early beginning would give you a head start, and it will give you a stronger grip on the foundations, which is extremely important, since the questions asked are type that are extremely related to concepts. So you will be getting a better concept knowledge, and it will give you more time to manage also. You can manage your education, your extracurricular activities, etc., coaching and etc. Now this journey would give you enough time to develop a higher critical thinking ability. And by testing your knowledge, by giving more and more tests, you can feel the real competition, not only from your peers, but also across the country. Right? Now you'll ask me, who will teach in this foundation course? We believe expert teachers can make expert students. So the people who have cracked the IIT themselves are gonna teach you in this foundation course. Right? They can share their experiences, their, those tricks they follow, those knowledge they have, they can definitely share it with you. And coming to syllabus, we will be focusing on 11th and 12th JEE syllabus. Starting from the basics, we'll take up to the advanced level problems. So coming to our classroom, this series or this elite batch is not on YouTube, Nana. You can find this in our live on SISYA class app. You will be able to access live quizzes. You will be provided live ranking system, and a continuous tracking of your progress will be provided to see where you stand it. Right? Now coming to doubt resolution or support we can provide you. We will be providing you with AI 24/7 doubt help system. You can upload your doubt in the form of text, message, etc. Because every student, they have different time of study schedule, right? Some might be studying in the morning, some in the night, some in the afternoon, right? For that, this is really helpful. And later, and coming to this, we also provide one-on-one mentor session. You can have more doubts cleared, more problems cleared, right? And you can also always contact your master teacher from morning 10 to evening 9. And minimum waiting time would be 2 minutes, and the maximum waiting time would be around 7 minutes. And finally, we would also be providing you with a highlight feature of AI plus mentor collaboration. Now coming to self-study. Your doubts are cleared and you want to practice what you have learned. We are providing you with daily practice problems, digital study materials, and daily worksheets to keep you updated on the topics you learn. Now finally, testing the knowledge that you have obtained, we will be conducting bi-weekly test and mock test and test series, Nana. And the original prices of this course for 8th, 9th and 10th would be 39,999, 44,999 and 49,999. Coming to multi-class packages, we have 8th, 9th and 10th for 89,999, 9th and 10th for 65,999 and 10th, 11th and 12th for 2 lakh rupees. There are no seats available in this 10th, 11th and 12th batch. I'm just telling you that. And remaining also nearly 18 or 19% seats are left. There's a hurry up and please book your seats. And coming to special offer, this is there until This JEE series is live in YouTube, where you'll be getting 8th, 9th and 10th for a flat 14,999, 15,999 and 16,999. Coming to multi-class packages, we have 8th, 9th and 10th for 39,999, 9th and 10th for 30,999, right? Please hurry up and book your seats in the SISYA class app. You can find the link in the description. Hope you all enjoyed this class. You can find our app on Google Play Store and App Store if you're using an iPhone. You can also scan this QR for downloading the app. Hope you all enjoyed this session, guys. Please like, share and subscribe. Have a great day, guys.